On your recursive homework, the recursive formula homework 7-8 skills practice, I want to go over 13, 14, 15, and 16 with you, okay? It says, for each recursive formula, write an explicit formula. For each explicit formula, write a recursive formula. So we're going to go back and forth with this. There are a few tricks because I really don't have a step-by-step guide. That's why I wanted to go through this with you so that you already have the answers, okay? So let's do number 13. 13 says A1 equals 38. AN equals AN minus 1 minus 17. N is greater than or equal to 2. Now, I'm going to move this away and move my notes up for everyone here. What? Is this a recursive or an explicit formula? It's a recursive formula. Okay, so we're going to go from recursive to explicit. Well, the first thing I have to do is figure out, is this an arithmetic or a geometric? What kind of equation is this? It's arithmetic. Okay, you're correct. So if you look on your notes where it says write recursive formulas, arithmetic looks like a n minus 1 plus a d. Okay? And a geometric is going to have something multiplied by the a n minus 1. So that's how we can tell if it's going to be arithmetic or geometric. But now that we know it's arithmetic, let's write arithmetic. Okay. We know it's arithmetic, so I know I have to use the arithmetic formula for my nth term, okay? Which is going to be an equals a1 plus n minus 1 times d. All right? Now, in order to fill this in, since we're writing an explicit formula, we're filling it in and simplifying it to the best of our ability. I have to know two different terms. I have to know the a1 and I have to know the d, correct? Okay, so A1. Do we know the first term of this sequence? Yes. What is it? 38. 38, because it was given to us right here. A1 equals 38. Okay? Do we know the d? It's negative 7. 17. Did I write it down wrong, or is it negative 17? Negative 17. Okay. So D is negative 17. Because in that formula a second ago, you had A n minus 1 is plus D. Well, this is minus 17, so that is our D. All right, so then what do? We fill it in. We say A n equals 38, n minus 1, and we have times negative 17. Okay? So we have 38. What is negative 17 times n? Okay. Negative 17 times negative 1? Plus 17. All right. So we're going to put our negative 17 in up front, right? Because that one is by itself. And then we have 38 plus 17, and that's going to give me what? 55. Plus 55. So your explicit formula would be an equals negative 17n plus 55. All right? So now I'm going to skip to number 16 because I want to keep this thought process going, okay? So I'll write out number 16 for us here. It says A1 equals 16. A to the n equals 4. An minus 1 when n is greater than or equal to 2. All right. So now, do I have a arithmetic or a geometric? A geometric, correct? Because it is in the form, this equation right here is in the form r times a n minus 1, correct? Do you see that? Okay, so we have a geometric. All right, and for the geometric nth term sequence equation, it is an equals a1 rn minus 1. So I still have to know the first term, but now I have to find my ratio. Do we know my r or my common ratio? What is it?
R is 4.
Yes, because look, y'all. r times a n minus 1, 4 times a n minus 1. Okay, so our r is 4. So what is our first term?
16.
What is our r?
4.
4. So we're going to fill in what we have. A-N equals 16 times 4 n to the minus 1. You're done at that point. Why are you done? Because the next step is you must figure out your exponent, and you have to take your 4 to the power of the exponent before you can multiply it by 16. Because you can't take 16 times 4, can we? Because the exponent is only attached to the 4. So then that is your answer. That is your explicit formula for that one. Okay? So now let's go to number 14. Now we're going to go from explicit to recursive. Okay? So let's do number 14. And we have AN equals 5N minus 16. Now, I want y'all to think about this, okay? On number 14, is this, do you think, a geometric or arithmetic? It's arithmetic. Hey, look. Arithmetic geometric sequence looks like slope-intercept form. A geometric explicit has this with the power to it. Okay? Do y'all see that? So if you're looking at this is going to be an arithmetic sequence. Okay. So for arithmetic, we need to be able to find A1, and we have to find our D. Okay? So let's go to, let me flip back here to our arithmetic. Since we're going to write a recursive formula, we need to get AN equals AN minus 1 plus D. We have to get to this form right here. So we don't have to know the first one right now, but we need to figure out D. How do we find D if we're just given AN equals 5N minus 16? Actually, we're not going to. Pay attention. Have I ever combined, in the last 2 days of notes, have we combined any n terms together? Is my D always attached to the n? Right here, my D was negative 17, y'all. I wound up with negative 17n. Do you see that? On my notes, when we were writing explicit formulas, my D was 10, I wound up with 10n. So my D is actually the coefficient of n. That is D. Okay? So now, we're going to write AN equals AN minus 1 plus 5. Okay? So we still have to find the first term, right? Because to do a recursive, you have to do the first term, and then you have to do the formula, and then you say n is greater than or equal to 2. So how would I find the first term? Well, what does the n stand for? What's my letter n stand for this entire time? The what?
The term that you're trying to find.
The term I'm trying to find, the nth term. So I'll look. I can say A1 equals 5 times 1 minus 16. 5 minus 16. A1 equals negative 11. Okay, so my recursive formula, A1 equals negative 11, comma, AN equals AN minus 1 plus 5, comma, if n is greater than or equal to 2. All right. Now, the next one actually, arithmetics are a little bit more difficult. It's really not that difficult if you realize that the D is the coefficient of n, and you just need to plug a 1 in to get your first term. That's really all that you're doing, okay? So let's look at number 15. It says AN equals 50, 0.75, n minus 1. All right, is this an explicit or a recursive formula? It's explicit. Okay, so knowing that, what I'm going to do is I'm going to flip to my explicit. And I'm going to see explicit, under explicit formulas, it is AN equals A1 R n minus 1. Do you see that? So look, this is in the form AN equals A1 R n minus 1. So what is the value of A1? 50. R is this. I just found my basic formula. There's numbers, so now I'm matching them up. So A1 equals 50 and R equals 0.75. So it is, everything is given to me. Now I have to write the recursive formula, right? So the recursive formula for a geometric sequence, if you'll go to writing recursive formulas, geometric, we need to change it into the form AN equals R times AN minus 1. Are you following me so far? Okay. So the only value I need to know is what? R, and what is R? Okay. So here we go. So we have AN equals 0.75. I'll just put AN minus 1. But to write the recursive formula, what is the first part of my recursive formula? What's the first thing you have to say?
A1 equals 50.
A1 equals 50 because it was already given to you. A1 equals 50. You write your formula, comma, if n is greater than or equal to 2.